Hello and welcome. In this video we're going to do another example of mathematical induction. We're going to show that for every positive integer n, that 1 plus 2 plus 2 to the power of 2 plus 2 to the power of 3 plus so on and so forth to 2 to the power of n minus 1 is equal to 2 to the power of the nth degree then minus 1. As always, the first step in doing proof by mathematical induction is the basis test, which is to see if this equation is true or holds true for n is equal to 1. So on the left hand side we have, when n is equal to 1, we have 2 to the power of 1 minus 1, which is equal to 2 to the power of 0, which is equal to 1. And on the right hand side we have 2 to the power of 1 and then minus 1. So we have that equals 2 minus 1, which is equal to 1. So therefore the left hand side is equal to the right hand side. So this passes the basis test. And if this statement holds true for n is equal to 1, I'm going to assume that it is true when n is equal to any integer. So I'm going to assume it's true for when n is equal to k. Alright, so if I sub in k into both sides of the equation, I'll get 1 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus dot 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 plus 2 to the k minus 1, and that should equal 2 to the power of k then minus 1. And note, I've just assumed that this statement is true. So if it is true, then the second test is called the induction test. And this is to see if it holds true for when n is equal to k plus 1. I'll put a question mark there to see if, because I'm going to test if it is true or not. Alright, I have two choices here as to how I approach this step. I can either try and equate the left hand side to the right hand side, or I could try and get the right hand side into the original form. In this case I'm going to try and equate the left hand side to the right hand side because I haven't done it in this fashion before. When n is equal to k plus 1, I'm going to add the k plus 1 term to the left hand side. And the k plus 1 term is simply 2 to the power of k. On the right hand side, the k plus 1 term is going to be 2 to the power of k plus 1 minus 1. So the left hand side of this equation equals 1 plus 2 plus 2 to the 2 plus 2 to the 3 plus dot 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 plus 2 to the k minus 1 plus 2 to the power of k. And I note that all of this up to the k term, or 2 to the k minus 1, is equivalent to 2 to the power of k minus 1, because I've assumed that the equation holds true for n is equal to k. So I'm going to replace all of this at the front with 2 to the power of k minus 1, and the 2 to the power of k remains at the end. And this is equivalent now to 2 times 2 to the power of k minus 1, and that can be expressed as 2 to the power of k plus 1 minus 1, because I've just applied my index law here, because 2 is a common base. And this, of course, is equal to the right hand side, as you can see. So again, for when n is equal to k plus 1, we're able to get the left hand side to equal the right hand side. So we've proven that this equation holds true for when n is equal to k plus 1, and that means it will hold true for any value of n where n is a positive integer. Okay, that's it. Thanks for watching. I hope you have found this video helpful. If so, please give me a thumbs up. If you are a math student, please feel free to subscribe for future videos that may help you on assignments or exams. If you have any question that you would like me to do a video on, please feel free to comment on any of the videos that you've seen. Thanks for watching, and I hope you learned something.